Good morning, student. Namaskaram. Today we are going to discuss one topic from 11th physics chapter name motion in a plane. Topic name parallelogram law. Okay, so this is a one important 4 mark. Okay, so in your question paper, it will be a state parallelogram law of vectors, derive an expression for the magnitude and direction of the resultant vector. This is a question. Okay, right. So first of all, we have to know what is parallelogram law. Okay, already we know that vectors. Vector is a quantity that suppose one physical quantity has direction with magnitude is called as vector. Yeah. So statement for this parallelogram law, which is like that. If two vectors, if two vectors are represented in magnitude and direction, because vectors has direction as well as value. Yeah. So by the two adjacent sides of a parallelogram drawn from a point, okay, then the resultant is represented in both in value, that is magnitude, and direction. Okay, so by the diagonal passing through the same point. This is a statement. Through the same point. Okay, so same point is I can write here. So same point. So yeah, uh, the statement for this paragraph law of vectors. If two vectors represented in a magnitude and direction by the two adjacent side of the parallelogram, okay. So already you know that the diagram of parallelogram, and then their displacement is also represented by the both in magnitude and direction by the diagonal passing, okay, diagonal passing through the same point, okay. This is a statement. So now I will draw a parallelogram diagram picture, okay. So which is like already you know that, like this. It just look like a rectangular, okay. So this is Q, this is S, this is O, this is P, and here A vector. So A dash, A cap or A dash, okay. So A bar also we can say that. So this is a B bar, and this is the resultant R bar, okay. So which is B bar? It is also B bar. Which is A bar? This is also A bar, okay. So the angle between that origin and this P is alpha, and between these two vector, because this is one vector P, is one vector. I will explain later. This is another one vector. There is an angle between these two vectors is theta. Okay, right. So, explanation. Let OP and OQ represent the two vector, any two vectors. Okay, represent the vectors. That is A vector and B vector. Which is A and which is B. So OP and OQ represent the two vectors A bar or A vector. Okay, like that. Okay. So this is also B vector. This is also A vector. We can say that A vector. Okay. So which is making angle theta. The diagonal means this blue line. The diagonal OS vector represent the resultant vector. So resultant vector, OS vector. OS vector represent the resultant between these two vectors, A and B, or OP or OQ, okay, and OQ. So this is the magnitude. This is the resultant. That resultant has magnitude and as well as direction. So to find the what is the value of this resultant, we have to extend a line that is OP. This is OP. Okay. We have to extend this line to some extent like that. Okay. So we can connect this point from here. So this is N. So extend the line OP into N and draw the perpendicular line from S to that position, that is Sn. So we now extend that OP into Pn. Just extend that line. So and then draw a one particular perpendicular line from the S. From the right angle triangle ONS, you can see ONS. This is the one right angle. So from the right angle triangle ONS, we can substitute that equations like um, Pythagoras theorem. Yeah, OS square, which is equal to ON square plus NS square. Yeah, this is a Pythagoras theorem. OS square is equal to ON square plus NS square. ON means here to here. So this whole point, which is a combination of OP plus PN. So OP plus PN the whole square plus NS square. Here you can see that A plus B the whole square. So A plus B the whole square means A square plus B square plus 2AB. So A square, OP is the A, so OP square, PN is the B, so PN square plus 2AB. So 2 into OP, PN, and then also NS square. Okay. So this is the OS square. OS means R. So R square. Because that it is represented by R. So R square. Then we can take the now another triangle PNS. PNS. This another triangle. So in that triangle PNS. PNS. In the triangle PN, which is equal to PS cos theta. Because we can take cos theta. Okay. So this is theta. So this is also theta. Okay. So theta means, cos theta means adjacent side by hypotenuse. So theta adjacent side PN. Hypotenuse, which is a PS. Okay. So adjacent side hypotenuse. So PN is equal to PS cos theta. Yeah. Because PN is equal to PS cos. That's why I am writing here Pn is equal to Ps cos theta. So Pn here, Ps cos theta. Yeah, Ps cos theta. So Ps, which is the value B. So because B vector, it has a value B. So Ps, we can replace as value that is B. B cos theta. Pn, which is equal to B cos theta. Like that, for ns, for that, take the sine theta for this triangle PNS. Okay, take the sine theta. Sine theta means opposite by hypotenuse. So theta opposite side ns, hypotenuse as well as same. That is PS or SP. Okay. So ns, which is equal to PS into sine theta. Yeah. Okay. What is PS value here? B. So ns equal to B sine theta. So ns here is P sine theta. Okay. It is now clear. Sorry, B sine theta, which is B cos theta, which is B sine theta. From this triangle PNS, we derive with that Pn is equal to Ps cos theta, that is B cos theta, ns equal to B sine theta. And then we can put it in that resultant equation. That is r square equal to, what is that? R square equal to OP square plus PN square plus 2 OP PN plus NS square. Yeah. So OP square is that. Okay. PN square. Already we have a PN, that is B cos theta. So O square. 2 OP PN means P cos theta. NS square. Already we have NS, that is B sin theta with whole square. Okay. So OP square. This is B square cos square theta. This is B square sin square theta. So B square sin square theta. And then this term only. So 2 into OP into B cos theta. Okay. So we can take B square as a common. So like that. Okay. So cos square theta plus sin square theta value 1. So we can neglect this equation. Okay. So now we will write like OP and B cos theta. Okay. OP square plus B square plus 2 OP P cos theta. Okay. From diagram, we have also value for OP, that is A. For the, because OP represent the vector A. So OP square means which is value. So OP is the value magnitude, that is A. Okay. So OP square means A square, because from the diagram we know that OP is the, OP represents the vector A vector. So it has a value A. So OP, which is the length or magnitude, so A square plus B square plus 2. This is A, this is B, and this is cos theta. Clear? This is a resultant. To find the resultant, we have to take roots. So like that. Okay. So root and 2 is cancel out. So R is equal to A square plus B square into plus 2AB cos theta, which is the value of or which is the equation for to find the value of resultant vector for A and B. For A and B, we have to draw one line with the diagonal passing through that same point. So that is the resultant of these two vector. To find the two vector value, to find the resultant of these two vector value, we have to put this equation. So A square plus B square plus 2AB cos theta. Okay, clear? This is a value magnitude because r cap r vector it has a value with direction. Now we find out that value that is called as magnitude. Another case to find direction because vector has a direction. So to find the direction of this resultant vector, to find the direction vector, we like that. This is B, this is A. Okay. So this is R. R makes an angle alpha with this vector. Okay. It makes an angle, some like that theta. Okay. So we can label it as alpha. So the resultant makes an angle alpha with vector A. So this is A vector, this is B vector. So okay. So okay, alpha. So in our diagram, this is O, this is P, this is N, this is S. Yeah. From our diagram, we can take OSN, triangle OSN. For this, we can take tan alpha. Tan alpha means opposite side by adjacent side. Yeah, opposite side by adjacent side. So for alpha, this is the opposite side. That is NS. Yeah, or SN. Adjacent side means this is this line. That is ON. Okay. Tan alpha equal to NS. And ON means OP plus PN because ON means OP plus PN. So we can like write like that OP plus PN. Okay. So tan alpha is equal to NS by OP plus PN. What is the value of NS, SN or NS? Already we have that is B sin theta. Yes. Already we have B sin theta. What is the value of OP? This is A. We can write as A. What is the value of PN? B cos theta. Okay. So this is the for angle tan alpha. So for to find the alpha, we can take tan into here. So which is tan inverse of tan inverse of tan inverse of B sin theta by A plus B cos theta. Okay. So this is the value of equation of alpha, which is the direction. To find the direction of the resultant vector, because the resultant vector is here. This is A vector. So this is alpha. Alpha values to find the alpha by this equation. So by this equation, we can put what is the value b and theta, and because theta, you know that from this vector to this vector. So we will have one value for alpha, so which determines the direction of r with respect to a. So that's why we can say that to find the resultant vector, the direction of resultant vector, this is the equation. Alpha is equal to tan inverse of b sin theta by a plus b cos theta, and alpha means that the angle between the resultant and vector a. Okay, this is 1 4 mark. Okay, we will discuss another one topic in next class. Thank you. Jai Bharat, Jai Hind, Jai Vidyashati.